section of 3.4, we're going to be discussing particle motion. Particle motion is the forward and back motion of a particle or a molecule. So before we do this, we're going to go over some definitions of how we represent position, velocity, and acceleration and speed. Our first definition is going to cover S of t. If S of t represents the position of an object, then the velocity of the object is given by v of t, which is the derivative of S of t. So if I give you S of t is equal to 16t squared plus 15t, then your velocity function is equal to the derivative of position, which is 32t plus 15. If v of t represents the velocity of an object, then the object's speed is given by the absolute value of velocity. So speed is equal to the absolute value of velocity, and remember, velocity is the derivative of position. Now this gets a little confusing because S is the first letter of speed, however, S is used for position. In example 2, we're going to look at how to read a velocity graph. So it's very important to note out that this is v of t, not x of t, and not s of t. So this represents velocity. So our x-axis is time and our y-axis is velocity. So as time starts to increase, we have that our velocity is going up, which means it's increasing. And then I know this looks constant, but the velocity is a constant number. So from t equals 1 to t equals 4, the velocity is 3. And then the object slows down to 0, so now it's not moving. And now at this point, it starts accelerating backwards, because now your velocity is negative, so you're moving backwards. And the car, or object, or particle is speeding up backwards. It's like putting your car into reverse and pressing on the gas. You're going faster backwards, and then you start slowing down. You're still moving backwards, but I know you're slowing down because we're about to approach 0. And from t equals, looks like 19 to 21, the object is stopped because the velocity is 0. And then it looks like it increases, so it's moving forward, and it's accelerating because our velocity is increasing. So the further away you are from the x-axis, the faster your speed is. Your velocity might be negative, but recall that speed is the absolute value of velocity. So my speed here, this is the coordinate 4, 3, and my velocity is 3. So v of 4 is equal to 3, and the absolute value of v of 4 is also equal to 3. Whereas right here, I have v of 12, and I'm going to get negative 6. So my velocity is negative 6. However, my speed is equal to positive 6. So speed is always a positive number. So now we're going to analyze it and talk about where we're moving forward, where we're moving backward, and so on. So we're moving forward on the intervals. Well, we have to look at wherever we're positive. So we're positive here, and we're positive here. So we're moving forward on the interval 0 to 8, and from 21 to 25. We're moving backwards wherever your velocity is negative. So that's all of these values. So we're moving backwards from, that looks about 8, until we get to 19. So we're moving backwards from 8 to 19. And then now we want to know where we're moving at a constant speed. So constant speed is given when the velocity is constant. Well, our velocity is constant here, and it's constant here. Even though we are stopped here, the velocity is constant. So we have a constant velocity on the intervals 2 to 5 and 19 to 21. So now we want to find the maximum speed. And the maximum speed is given when the absolute value of velocity is the largest. In other words, we want to know when is this thing the furthest away from the x-axis. Now I do want to caution you that people will often put either this value or this value because it's the largest positive. However, we want to find when is the distance the furthest, and the distance is the furthest right here. So this happens at v of 12, which we get -6. So my speed is equal to 6. So I have my maximum speed at t is equal to 12.